SRE, observability, automation is key to be free. Don't you see it's a better way now?
Welcome back to Performance Time. I'm Stephen Townsend, and this is the show about site reliability and performance engineering. In the last episode, I introduced containerization and Docker, and I promised I'd do an overview of Kubernetes. So here it is. Now, the reason I'm talking about Kubernetes, a really specific technology, is that if you are an SRE, there is a fairly high probability that you will be interacting with and working with Kubernetes at some point. So what is Kubernetes? So last time we talked about Docker, which is an engine for running containers. Now, Kubernetes is a container orchestrator. It's designed for managing a large group of hosts and containers, which we call a cluster. Now on that, there's some terminology, and as we step through it, I think it will explain a bit more about Kubernetes and what it's all about. We talked about containers last time. A container is like a virtual operating system running a single service or application, plus all of its dependencies. Containers need a container engine like Docker to run, so Kubernetes doesn't remove the need for a container engine. So Kubernetes and Docker work together to create our container platform. A pod is a new terminology which we don't talk about in Docker by itself. Now, a pod is the smallest unit that can be deployed and run in Kubernetes. Each pod contains one or more containers which share the same storage, IP address, and configuration. Now, from my experience, there's generally a one-to-one relationship between pods and containers. And many people use those terms interchangeably most of the time, but technically, a pod can have many or multiple containers inside it. Pods are created and destroyed continually. They are not as persistent as a virtual machine or a server that sits there and remains constant for long periods of time. So there's pods. And inside pods, there can be one or more containers. But where do pods reside? They reside on nodes. So nodes are worker machines used to run a Kubernetes workload. A node could exist on a physical or a virtual computer. So you might have a Kubernetes cluster, which is just one node, for example, sitting on an EC2 instance. So at an oversimplified level, each node is a server which we're going to create pods and run them on. Now, there are actually two different kinds of nodes. There are worker nodes, and these are the computers or the hosts that run the application containers. Worker nodes are made up of different components. I don't want to go into the detail too much, but part of it is that they have some networking and they have a process for handling communication called kubelet, and also they contain the container engine, for example, Docker. So those are worker nodes, but there's also master nodes. And master nodes are responsible for the overall management of the Kubernetes cluster. The master nodes handle scheduling. They also have an API server for interacting with the worker nodes, and they keep a track of the cluster and the state of all the components. Okay, so we've done containers, pods. So we've got these pods and they're running on a node, and lots of nodes together is called a cluster. So a cluster is Kubernetes terminology for a collection of nodes, which in turn host a number of pods. Okay, so that's the terminology, and that explains the hierarchy or the general high-level structure of Kubernetes. Kubernetes is pretty cool because it's driven by configuration. So you tell Kubernetes, the engine, about the nodes and the pods that you want to create using something called controllers. So configuring these is done using YAML files, and it can be done and changed dynamically on the fly. And then it's up to the Kubernetes engine to make whatever you've asked for come to fruition. The last thing worth mentioning is that there's something called services, which are another important part of Kubernetes because services provide network connectivity between the pods on a host. Okay, so let's say you are now looking after a Kubernetes platform. How do you administer it? What is it all about? So an engineer who wants to interact with Kubernetes will often install a command line tool on their local laptop called kubectl or kubecontrol. This is available on Windows, macOS, or Linux, among other platforms. So through kubectl, you can probe and query the state of your cluster. You can show the number of pods running and what they are, what state they're in. You can print out logs from one of your pods. You can even SSH onto one of your containers and run Linux commands to investigate an issue. Kubernetes also has a web UI called the Kubernetes dashboard, which is a visual way to do most of, but not all, that you can do in kubectl. Kubernetes dashboard provides resource usage graphs to give you a visual representation of the health of your platform. So although Kubernetes dashboard exists, all of the teams that I've worked with who use Kubernetes use Prometheus to monitor the health of the cluster. So Prometheus is an open source external tool, and it provides metrics on the state of the pods and the nodes and the overall cluster. This is commonly pulled into Grafana, into dashboards, and you can set up alerts either using Prometheus Alert Manager or Grafana itself. Now there's a couple of different ways that you can implement Kubernetes. You can manage it yourself. So have some VMs on premise, maybe some EC2 instances in the cloud, and you install and run Kubernetes all by yourself. This provides you absolute control over your Kubernetes cluster, but the downside is you have to manage the infrastructure as well underneath it. The other option is that cloud providers offer hosted Kubernetes services where you don't need to manage the underlying hosts at all. So examples of this include Amazon EKS, the Azure Kubernetes Service or AKS, or the Google Kubernetes Engine, GKE. So there's pros and cons to both approaches. There's definitely less overhead when using a hosted option, but you have less control and visibility of what's going on under the covers. Now, what if you want to learn more about Kubernetes and get some hands-on experience? How do you go about that? Well, there are some great Kubernetes training resources online. Now, if you have access to LinkedIn Learning or Pluralsight, I know for a fact that there are some great courses on both of those platforms. There are many options, but one great tool for running your own Kubernetes cluster on your local laptop or VM is Minikube. I really like Minikube. I think it's a great tool for developers or anyone wanting to get familiar with Kubernetes. A word to those running Windows though, Minikube requires a virtualization platform to run. Because my laptop had some access restrictions put in place, I was unable to get Minikube working with Hyper-V. I couldn't create the required network interface. So if you run into the same issue I did, then you can download and use VirtualBox instead, which works absolutely fine, although it is a little bit slow at times. I have heard that if you are on Windows and you use the Choco Package Manager, that it's much simpler for installing Minikube. Now, it's pretty challenging describing Kubernetes without any visual aids over a podcast, but I wanted to follow through on my promise to have a go at explaining it as simply as possible. Next time, we'll be talking about some of the key SRE concepts that I've been grappling with lately, including defining SLIs and SLOs, and what good observability looks like. I also want to talk about the term cloud native and what it really means, as I have been misunderstanding it for many years. That's all from this episode of Performance Time. We'll see you next time. And if you're on LinkedIn, I have posted a blog on transitioning from performance engineering into SRE, so check that out if you think that will be of interest.